12. 6. What is the mass number? 12, but exactly it is given 12.01. Now I want you to focus on this number 12.01. What is that? What do you understand by atomic mass?
1 mole.
Forget about moles now. We did not study about moles in lower classes. So far, when I ask you what is the atomic mass of carbon, what do you say? 12, round off, right? Now, what do you understand by atomic mass? Kachina atomic mass imedi? Weight? You mean the exact weight of that carbon atom, ina? No, that is your thinking, ina. Like for example, my weight 61. Actually, it's 65 more, I don't know. Okay, but you are saying it is like the actual body mass. You feel that 12.01, the individual atom gi way beta is that what you think, ina? Yes, that is what we taught you. In a way, we taught you, okay, carbon gi mass of the 12.01. But actually, this value is not the case. Okay, this is not the absolute mass of that carbon atom. Now remember, our carbon, the Sudhi, they exist in a form of isotopes now. What are isotopes, class? What are isotopes? Carbon, isotopes, carbon 12, carbon 13. Push. Then chlorine 35, chlorine 37. These are isotopes now. Then carbon 12, carbon 13, yes, then, yes, Kachula Jamya?
Same atomic number but different mass.
Yes, so these elements, they will have same atomic number, that's why it is chlorine, chlorine, more, 17 atomic number. So here, remember, atoms exist in the form of isotopes now. They have different masses. For example, carbon 12, carbon 13, chlorine 35, and chlorine 37 here. Okay. Now, in the periodic table now, whatever number you see there, bottom now, what you have been seeing, atomic mass, they have taken care of these isotopes also. So what you see there, carbon 12.01 is actually the weighted average of these isotopes now. Okay. And remember, isotopes ki mass they have averaged that mass and then considered their relative abundance also. Now relative abundance Lavachin, for example, carbon with the mass 12, carbon with 13, they exist in different proportions in that space now. Okay, so relative abundance, it is there given to you. Okay, now let's see how they found out this value. Okay, 12.01. I will give you an example here. For example, this is the question now here. Calculate the average relative atomic. Forget about relative atomic mass right now. Let's see here. Chlorine isotopic. Okay, isotopes of chlorine 35 and 37 occur in a percentage of 75 and 25 now. Which means chlorine has two isotopes. Chlorine 35, chlorine 37. So what is the relative abundance now? In atmosphere, what proportion of chlorine 35? What is the percentage of chlorine 35? 75. So rest will be chlorine 37. So 100 minus 75? 25. So out of 100, okay, percentage 100, chlorine 35, the high to more. Which means in atmosphere, let's say if you could pick one chlorine, the chlorine with the mass 35, there is high probability that you can find this more. That is what you can pick because the percentage high dubate. Okay, that is the meaning of abundance. Okay, now when we find this now, average mass kadepi beni say watching, it's very easy. What you have to do is average watching first we add, then divide yes. So now here, how are we going to find this one is now chlorine 35 percentage comes to 75% means it is out of 100. Of that is Kajimo chlorine ki mass kaji bimidi mein 35. Then you add the next one, chlorine 37. What is the percentage? 25. So 25 out of 100 into Kachibego mass 37. Now can you try to find the answer for this one? What is your answer? Did you find? Did you get 35.5?
Yes.
Yes. So that is what we see in your periodic table. Now let's go back. Okay. Now look at this one. Now chlorine. Here. Chlorine, can you see here? 35.45 something. Do you see this one? Now that mass is actually, they have taken care of this isotope's relative abundance. They have calculated the weighted average mass. Haguika. So did you understand how you got this one? That is actually not the actual weight of each individual chlorine atom. Tuka. Okay. It is the weighted average mass. Okay, this one. So whatever value you see there, it is the weighted average mass of that element. So they have taken care of isotopes, its relative abundance. Okay. Now 35.5 Lavachin. Now, is that the actual weight of individual atom? Chlorine ki. More. So, this is not the actual weight of that individual chlorine atom. It is the weighted average mass, but the scientists, they took one step further. This one, it is actually compared to, do you see, carbon 12, carbon 13. This is the first isotopes of carbon. More, carbon 12. They compare this with this carbon 12 isotopes of carbon now. Tuka. The reason they did is because our atoms are really small, more atoms in molecule. So what happens is you cannot weigh them. There is no, you cannot use a scale, kg or even grams to weigh this individual atom now. Okay. So what happened was the chemists, they came up with a method to indirectly weigh this carbon or each individual atom of an element. Now what they introduced was this relative scale of atomic weight. Kachilo? Relative scale. Now relative means, what do you mean by relative? The other class said relative lamedi pincha ino. But in chemistry it's not pincha mare. What do you understand if I say the relative speed, Lavachi? Relative means? Yes, we are comparing our speed with another one more. So scientists, what they did was, they found out that atoms are so small that you cannot weigh them directly. So they introduced a reference point, material. Chituka. Ani relative lavachi. Reference point chi kongi. Choose penu. Ani element chi. Atom of. So ani relative T, they compared it with carbon 12 isotope. Why carbon? Because carbon element at that time was readily available. Okay. And carbon 12 isotope was cheap also. And most importantly, it was stable. That's why they took this carbon isotope, this 12. Again, remember 12 Latalu, that is not the actual weight of this carbon. They just put, the scientists, they came together, agreed that, okay, this carbon should have this number 12, say. To make the calculation easier, they took it as 12, gave the isotope as just 13, say. But this is not the actual weight of that individual carbon, okay? So they just gave a number to make it easier. Now, relative scale, how does it work? For example, it is also given in the note last year. I gave you that mole concept chemo. Let's say right now most of you in class 10. So, average, let's say your age is 16 more. Your age is 16, your father is 48 years old and your sister is 8 years old. You are here now. We are going to keep you as the reference point. Tuka. Now you are 16 and this is 48. Now we want to see by how many times your father is older than you. Come to times. You are 16 your father is 48. Huh? Kamchilo? Your father is 3 times older and your sister is half your age, remember more. Yes? So 0.5 meaning you assigned yourself the value of 1 remember more. So 1 measure, my father is 3 times older and my sister is half your dalu. It becomes easier to guess more. The upper the 48, numdiani, ngara the 16 labdalu. You can't get much information. But if I say my father is 3 times older, my sister is half my age, so the reference show, it becomes easier, more calculations this way. That's the logic of, that's how the scientists came up with this relative scale. So instead of your age now, the Kongi reference point they kept carbon 12 isotope and then all other elements or atoms that were discovered Kongi mass it was compared with that carbon 12 isotope. That is the meaning of relative. Okay, so let us see relative atomic mass ki definition or molecular mass. Okay, so see here. Here. Atoms are extremely small. For example, hydrogen atom, look at the mass. Ani di kongi absolute weighting. The true mass that you achilab demo. 61, that is my true mass mush. Ani zume here. Hydrogen gi absolute weight the 1.67 into 10 to power minus 24. Which means very light, remember minus 24 kg. Oxygen atom 26.5 10 to minus 24, remember. This is the actual mass. But this is not what is given in the periodic table. No. Because periodic table gives the absolute weight, remember, the exact mass manually. So these masses are so small you cannot use bigger unit. This is incorrect actually. To use even gram or kg, okay? Because they are very, very small to weigh more. So the chemists, what they did was they invented the relative scale. Compare very data more. The carbon 12 isotope, let us keep this as reference as 1. Then so elements, how many times it is heavier or how many times it is lighter based on carbon reference. So that is the meaning of relative scale. Okay, so it will allow them to perform useful and accurate calculations. Ani reactants the product this gamchi amount bago bega mo ani this okay, so these are compared to standard or reference measure. So reference the kachilo carbon 12 in this relative scale na. Okay, then carbon 12 isotopes. So now here relative atomic mass or also given as AR, R the relative, A the mass. Okay, relative atomic mass. So it is the weighted mean mass of an atom of element compared to 1/12 of the mass of an atom of carbon 12. So the weighted mean mass of an atom, this is how we found out 35.5. You remember? Average bani de anigi isotope ki mo. Hani weighted average mass. Then you compare with 1/12 the mass of carbon 12. So carbon 12 ki mass that the gachi number. Mass is 12. So 1/12 of that mass the gamchimo. 12. They are comparing with not the whole of 12 mass the more. 1/12 of that carbon 12 mass load. What does that mean? How did you get 1? Times half? Times half? Huh? They compare to 1/12 mass. Remember carbon 12 ki mass. The mass 12 remember ani ki 1/12 part the bailo, which means 1/12 of that is how much? Kamchimo? 1/12 of that mass of that carbon 12 isotope ki mass kamchimo 12. So what is your answer? 1. Remember nothing. When you take 1/12 of carbon 12, you keep that, you are keeping that as 1. Like for example, dachinga 816 labdaludi, I am keeping my reference point as 1 lachimena mo. So that's why they took 1/12 of the mass of carbon 12 the kamchimo 12 the mena isotope carbon 12 the mass. So ani 1/12 part baudalu tamchi ani reference point the 1 jado zumbe jume mena the mo. So that is the meaning of relative atomic mass. You are comparing that weighted average mass, that's 35.5, and you're comparing with 1/12 the mass of carbon 12. So this is how we write the formula. Average mass of one atom of an element, that's isotope with relative abundance, find way more. Then you're comparing it with 1/12 the mass of atom of carbon 12. In other words, this RAM will tell you the number of times one atom of an element is heavier than 1/12 the mass of an atom of carbon 12. Meaning, the chlorine we found the value 35.5 weighted average mass more. Now, compared with this 1/12 the mass of carbon 12. Mush. That means, ani the reference point one image, your chlorine is 35.5. We are saying your chlorine is 35.5 times heavier than 1/12 the mass of carbon 12. That is the meaning of relative atomic mass. Did you understand what is relative atomic mass? But this is not the absolute mass of individual carbon atom. We are just saying your chlorine is 35.5 times heavier. Like you are saying, you are 3 times older. Labdaludi, 3 is not the actual age of your father. Remember, we are just giving a value. Kamchi times ki heavier, remember. That is the meaning of relative atomic mass. You are saying 35. Your chlorine atom is 35.5 times heavier than 1/12 the mass of carbon 12, because 1/12 of 12 the 1 be more. Ani kamchi times heavier ani the relative. Because you are comparing, for example, my father is 3 times older, Lavaji, 3 years older. Is it correct? Is it correct to use the unit? When you compare it, it is not wise to use the unit. Amchi times heavier, amchi times lighter, we don't use unit. So whenever they ask you to find relative atomic mass or relative molecular mass, because you are comparing it with something else, there is no unit. Okay? Did you understand why there should not be unit? Because we are just saying this element is this times heavier. There is no unit when they ask you to find relative atomic mass. Now, did you understand how to find relative atomic mass? Relative atomic mass, the average mass of one atom of element, and the relative abundance, the isotope take care there. Then you compare it with 1/12 the mass of carbon 12, the relative scale. Now look, carbon 12, this standard pe bubble mein, reference point pe. Hani ki 1/12 part pe amedi, so that they will be given the value 1. So 1 we know that Kamchi times heavier, it becomes easier. That's why it was given the reference 1/12 the mass of carbon 12. Why we are using this relative scale is to very large or small numbers can be compared relatively easily. Kamchi times heavier more. Okay, another example, let's see whether I have it. So 35.5, one chlorine atom is 35.5 times M. If they ask you, the relative atomic mass of chlorine is 35.5, what does that value represent? They're just saying our chlorine atom is 35.5 times heavier than 1/12 the mass of carbon 12. How much times it's heavier?